Hello, good morning. Hi, students. Welcome to the most important numerical sections of engineering chemistry. In this video, I wish to discuss the determination of numericals based on determination of hardness by EDTA method. I think that this question having most probably having weightage 7 marks. It's a huge problem, but you didn't think about the size of the problem. Just understand the concepts, then you can solve it in an interesting manner. So let us move to that. Okay, so this is the question. First of all, I read the question. 2.8 gram of calcium carbonate was dissolved in HCl and the solution is diluted to 1 liter of solution, and 1 liter and 100 ml of this solution required 28 ml of EDTA solution, while 100 ml of hard water, that is a sample water, required 35 ml of the same EDTA. On other hand, 100 ml of the boiled water sample, when titrated against the same EDTA, required 10 ml of EDTA. So calculate temporary, permanent and total hardness. Is the problem is simple? I think that no, I know this is not a simple problem, but we can solve it in very easy manner. Did you ever notice that I wrote this question with using different color? And first sentence I wrote in red color, second one blue, third one green, fourth one it's a type of rose, and fifth one or magenta, and fifth one is black. Each sentence provides some valuable information for us. Once again, first of all, let us read the first sentence, that is 2.8 gram of calcium carbonate. What is the speciality of this calcium carbonate? Speciality is calcium carbonate is we used as the standard salt for EDTA titration. So 2.8 gram of standard salt was dissolved in HCl. I think that in my last video, that is the derivation part, I discussed the formula for procedure for that. That is 2.8 gram of the calcium calcium sulfate cannot be dissolved in 1 liter water. So first of all, let us dissolve in HCl. It will evaporate it into dryness. Then the obtained residue can easily dissolve up to 1 liter. So that much procedure is included in this in one sentence, that is 2.8 gram of calcium carbonate was dissolved in HCl and solution, and the solution is diluted to 1 liter of solution. So we know that is the information for the preparation of standard. 100 ml of this solution, which means the standard solution required 28 ml of EDTA solution, which means there is a titration is carried out between the standard salt versus the titrant, that is standardization step, while 100 ml of hard water, that is the sample water, required 35 ml of same EDTA, that is the titrant is EDTA versus the sample, that is total hardness. On other hand, 100 ml of boiled water, we know that what is the importance of boiled water, because boiled hard water remove all the temporary hardness. So the obtained result or that information or this sentence provide an information about permanent hardness. That is, on the other hand, 100 ml of the boiled water sample when titrated against EDTA required 10 ml of EDTA. Calculate temporary, permanent and total hardness. Okay, so let us discuss the steps. The first step is the preparation of standard solution. We know that this titration is every titration has 3 steps, mainly 3 steps. That is, the first one is the preparation of standard. From the mass of the salt, the primary standard salt, we are estimating the concentration. So that information, or we are doing that particular step for the preparation of that particular, or to calculate the concentration of the standard solution. Second step is the standardization. Standardization of a solution means we are estimating the concentration of a component or a solution using a standard solution, and that the concentration of that standard solution is known for us. So here here the titrant, actually in standardization we are estimating the concentration of the titrant. In this titration EDTA is the titrant. So we are estimating the concentration of EDTA by using the data from the standard hardwater for the primary standard solution. So from the volume of EDTA, volume of standard solution of titration between standard hard water and EDTA, and using the concentration of standard hard water, we are calculating the concentration of EDTA. Just remember the steps, that's enough. And the third step is the estimation of total hardness from the volume of EDTA for the titration between the sample solution versus hard water, the concentration, and the concentration of EDTA we are estimating the concentration of hard water, that followed by calculating total hardness. Okay. The fourth step is the determination of permanent hardness from the volume of EDTA for the titration between boiled hard water and EDTA, and also using the concentration of EDTA and calculating the concentration of boiled hard water, followed by calculating permanent hardness. And the fifth step is estimation of temporary hardness, that is calculated by using a simple equation, that is total hardness minus permanent hardness. So dear students, just by heart or just understand this table. If a mass is be provided for you, or if information about the standard salt is provided, that information is used for the placed under the step preparation of standard hard water. Then the data for the data obtained from the titration between EDTA versus standard hard water, that information can be used for standardization of EDTA. The information from titration between EDTA versus sample hard water, we can use that for the estimation of total hardness. Then the information from the titration between EDTA versus boiled hard water, we are using that information for estimation of permanent hardness. So let us discuss each steps. The first step is crack the first sentence, that is gram is provided, that is the CSE authorized standard. So we can say that this is the preparation of standard hard water. And the sentence is 2.8 gram of calcium carbonate was dissolved in dilute HCl or HCl, and the solution is diluted to 1 liter. We just require these two values only. So we can say that from this sentence I can write that 2.8 gram of calcium carbonate in 1 liter solution. I can easily simple write. Then we need to calculate the concentration of this solution or the standard hard water. How? Then we can just calculate the amount of this calcium carbonate in 1 ml. So the calculation is simple. Then let's just convert this gram into milligram and liter to milliliter. So we get 2800, that is 2800 milligram of calcium carbonate in 1000 ml of solution. From that we get 2.8 milligram of calcium carbonate in 1 ml of solution, that we take as the concentration of standard hard water. Just a simple step. So so we are using this 2.8 as the concentration of standard hard water. Okay, next step, the information give, I said that this is the second sentence, give this 100 ml of this solution, that is the standard hard water, require 28 ml of EDTA solution. That is the information. Here this is a titration is taking place between EDTA versus standard hard water. So that is the information for standardization. By cracking these equations or for the sentence, we got this information. Volume of standard hard water, that is 100 ml. Did you see that? Volume of EDTA used, that is EDTA, it can be 28. And these two informations more we know, that is standard hard water concentration. Concentration of standard hard water, just as mistake, that is 2.8 milligram of calcium carbonate in 1 ml. Then we don't know the concentration of EDTA, that I know. We know the basic equation. What is the basic equation? Concentration of EDTA into volume of EDTA is equal to concentration of standard hard water into volume of standard hard water. That is SHW is the standard hard water. So what is the concentration of EDTA? By rearranging the equation, we get the concentration of EDTA is equal to concentration of standard hard water into volume of standard hard water divided by volume of EDTA. Just substitute the values. So concentration of standard hard water, we know that is 2.8. volume of standard hard water, that is equal to 100 by 28. We get 10 mg of CaCO3 equivalent hardness. That's finished. Let us move to the next step, that is the estimation of total hardness. So the information is like this. Given that 100 ml of hard water required 35 ml of EDTA. Hard water versus EDTA. By cracking this equation sentence, we get this information. Volume of hard water, that is equal to 100 ml. Volume of EDTA for this titration is equal to 35 ml. Just keep it in mind. Concentration of EDTA that we previously find on the next previous slide, that is 10 mg, and the concentration of hard water we don't know. How can you calculate it? So we know the equation, concentration of EDTA into volume of EDTA, that is T for this titration, T, and concentration of hard water into volume of hard water. We need to calculate concentration of hard water by concentration of EDTA into volume of EDTA by volume of hard water. Just substitute the values, that is 10 into concentration of, that is 10 into 35 by 100, that is 3.5. Okay, then we need to calculate concentration total hardness. Just multiply this value by 1000, because this is the concentration or the value or the amount of substance in 1 ml. We need to calculate in 1000 ml. That's why we are multiplying using 1000. So we get 3000 milligram per liter or ppm. Okay. So next step is the estimation of permanent hardness. So the given information is that 100 ml of hard water required 10 ml of EDTA. Just write which are the informations. Simple. Volume of boiled hard water is here there is a small mistake, the boiled is be there. Boiled hard water is 100 ml. Volume of EDTA is 10 ml. Concentration of EDTA that we know, that is 10 ml, because all the titration, that is for this problem, concentration of EDTA is the same. Concentration of boiled hard water we don't know. So we know that the equation, that is concentration of EDTA into volume of EDTA for permanent hardness, that is the P that is represented, that is equal to concentration of boiled hard water into volume of boiled hard water. We need to calculate the concentration of boiled hard water. How? Concentration of boiled hard water is equal to concentration of EDTA into volume of EDTA of permanent hardness by volume of boiled hard water. So that is equal to 10 into 10 by 100, that is equal to 1 mg. So by substituting, this is the 1 ml concentration, we need to calculate 1000 ml, that is the permanent hardness. So concentration of boiled hard water into 1000 is equal to 1000 mg barrel or ppm. Simple. Temporary hardness can be calculated from the same equation, that is total hardness is equal minus permanent hardness. So substitute the values, 3500 minus 1000 is equal to 2500 ppm. Very simple. So the just simple thing is that just analyze each and every sentence and understand which are the informations. Okay, so once again, if you move to that once again, please keep it this table once again. So if the mass of the salt is provided, that is for preparation of standard hard water, titration against EDTA versus standard hard water data for standardization of EDTA, titration between EDTA and sampled hard water required for estimation of total hardness, and titration between EDTA and boiled hard water for estimation of permanent hardness. I hope you will understand. Please work out the similar problems. Okay, have a nice day.